Hello everyone. In this video we are testing routing, or mainly we are testing floating static routing. So we have site 1 here, which is represented by this PC and this switch and router, and we have site 2. We want the traffic to go from site 1 to site 2 through ISP1 in normal days or normal pattern, which means if ISP1 is up and ISP2 is up, then the traffic goes through ISP1. But in case that ISP1 is down, we want the traffic to go through ISP2. So if this link is down and this one is down also, both are down, we want to make sure that the traffic goes through ISP2. So in this case, the traffic goes through this link. Now, this is just a very simple representation. Typically, it is enough for one link to go down for the traffic to be diverted to the other side. But for our small setup, we need to make sure that both links are down to make sure that routing goes to ISP2 from both locations. So let's move to the lab and set up this in our packet tracer and test everything. We have the IP addresses already. If you go down here, these are the IP addresses we want to set up, and hash or this 4 hashtags are mainly the student ID. In our lab, I will only use the router names and PC names without any student ID. So let's move to packet tracer and set up this in the lab. To save some time, I have configured the IP addresses for devices. So the IP addresses and default gateways are already configured for PC1, PC2, and the routers. And now our focus is mainly on building the default routing. Now, you know, in packet tracer and actually in any logical topology, we typically mention only the subnet mask, the subnet and subnet mask, and then at every interface we only mention the IP address for that interface, which means we need to add 10.0.0.10, this is the PC, 10.0.0.1, this is the router, and the same here, 10.0.255.1 is this side, .2 is this side, 10.0.255.6 is this, and .5 is here. So we know the full address for each interface. We only need the subnet and the exact address to build the full address. I have already configured the IP addresses to make things faster, and now we can focus on the routing setup. So to start with, we need to configure the static routing in the ISPs. So every ISP should have a way to reach both subnets. I will start from ISP1. We can reduce the window just to make sure that we can see the IP addresses while doing the configuration. So if you see here, this is the show run, and we don't have any routing. If you try the command show IP route, we have only the connected subnets and local addresses. Local addresses are /32, they represent the IP address for the interface itself. Connected subnets are the subnets. We have two of them, one over this interface and the other one over the other interface, and we have two local addresses for the interfaces themselves. So I will start by configuring the static route that points to site 1. So IP route 10.0.0.0 255.255.255.0, which is this subnet. The prefix is mapped into full dotted decimal notation in Cisco IPv4 routing commands, and the next hop is 10.0.255.2. We use the same command to point to this next hop for this subnet. So the subnet is 10.0.10/24, which means 255.255.255.0. By using the arrows, I can go in history to the previous command and just modify the IP address. Now the next hop is, if we see here, let's reduce this little bit also. The next hop is 10.0.255.10. So we come to our command here. It is here. So instead of 2, here it is 1, and here this one is 10, which is this interface here. So we are telling the router, if you want to send traffic to this subnet, just send it to this next hub, and this next hub will take care. Now for this router, this is connected interface. It doesn't need routing to reach this interface, and I have already configured the default gateway in this PC to point to 10.0.1.1, which is this interface. And the same here, I have already configured the static IP address on this PC to be 10.0.0.10, and the default gateway is 10.0.0.1, which is this router. So after configuring this static route, let's see what we have now. So IP route. So we have 2 new static routes. We don't have any default route in this ISP. In my setup, I don't have default route in this ISP. And as you can see here, we have 2 static routes, one of them pointing to 10.0.0.0 with next hop as this interface, the other one 10.0.1.0 with next hop as this interface. I should be able to ping BC1 now, and BC2 and BC1, because for this router, we know that to reach the BC1, this is the next hop. This router has already the subnet as connected. The BC has the gateway as this router, and this router knows how to reach this router because it is connected. There is no need even for default route. So let's do it. Let's do a test. Ping 10.0.0.10, which is 10.0.0.10 is this PC. Yeah, it is pinging. We can try even the other one, which is PC2 10.0.1.10. We can try even trace route, although it is clear, but just to show you. So if you use trace route, then 10.0.0.10, which is PC1 on this side. So the next hop is 10.0.255.2, which is this router, and then the PC directly. If we try trace route to the other PC on the other side, it goes to the next hub here, which is 10.0.255.10, and then the PC2. Now this router is good, all good. We can write mem to save the configuration, which is equivalent to copy running configuration to startup configuration. Now we need to do the same steps in this router here. So we click on this router, and there is no routing right now there. We need to add the routing. We use the same setup. I'll reduce the window a little bit so we can see the IP addresses while I do the configuration. Now if you see show IP route here, we have only the connected subnets for these 2 interfaces, and we have the local IP addresses for the interfaces themselves, like 32. We conft then IP route. I need to create a static route for this subnet, which is 10.0.0.0 and 255.255.255.0. The subnet mask /24 as a prefix is 255.255.255.0, and next hop now is 10.0.255.6, which is the IP address for this interface. So 10.0.255.6. we repeat the same command, but now for the other subnet 10.0.10/24, and the next hop will be 10.0.255.14. So I use the same command. I use history. It is just arrow, the up arrow to see the previous command in history, and then 14, which is this interface here. Now we have these two static routes. Let's do some testing, some verification first of all. Show IP route. So we have these two static routes here. Let's make sure that we can ping 10.0.0.10. And for sure we can, because the same thing, we have static route here and this is connected subnet. And for the PC, we have the default gateway pointing to this router and this to ISP2. We do the same for PC2 and we can. And for sure, if we try trace route, the traffic goes through this interface here, 10.0.255.6, and then PC1. And if we trace route to the other one, it is the same. Now the main point is configuring the default routes and the floating static route on R1 and R2. Let's save the configuration here. And now we are ready for our testing. Now we cannot ping from PC1 to PC2 because we have no default route. Router 1 has no route pointing to PC2 or to pointing to this subnet. And the same on router 2. Router 2 doesn't have any route pointing to this subnet. Let's see the setup in router 1. So this is router 1. Let's reduce the window a little bit and maybe put it in this side so we can focus on, we can see the subnet at the same time we can read the configuration. So we have no routing right now here. If you go see show IP route, we have only the connected. We have three interfaces here. So 3 connected subnet and 3 local addresses. So we have the connected for the Ethernet subnet, and we have the local for the Ethernet interface. Then connected for serial subnet, local for serial interface, connected and local. So actually these are not serial, they are gig, but I mean for the point-to-point links. So we have 3 connected and 3 local. Now we can try to ping BC2 just to make sure that we cannot reach it. And for sure we cannot, because this subnet is not in our routing table and we don't have any default gateway. So this router has no way to access that subnet and it will drop any traffic that goes to that subnet. So if you go to PC1 for example and we try to ping the other PC, if we try to ping 10, so we are in PC1, we are trying to ping PC2. And for sure we cannot. BC1 will send the traffic to its gateway. The gateway has no route to the subnet, so it will simply drop the traffic and the user will not be able to ping. So let's go back to our PC1, to our router 1, and we configure a default gateway. So the default gateway is needed if we want to configure the router to send everything to an ISP or different router. So instead of configuring the subnet, maybe you have many subnets here and many other subnets around, and instead of configuring them one by one, we can simply send all the traffic to ISP1. So now we will configure a default gateway in router 1 that says if the destination is not any of the interfaces that are directly connected to me, just send it to ISP1. ISP1 will take care. So this is the idea of default route, and we will set the administrative distance to be the default of 1. We will not set it, we will leave it the default of 1. So default route is 0000 and the subnet mask is 0000, which will match any subnet. And the next hop in this case will be 10.0.255.1. 10.0.255.1. Now, this is not enough for connectivity between BC1 and BC2. We need to configure a route back from router 1 default gateway pointing to ISP1. The routing should be from both directions, so we now set up the traffic to go this way, but we need also to make sure that the returning traffic has routing to go back to BC1. So we go to router 2 and we do the same. We add a default route, conft IP route 0000 and the next hop is 10.0.255.9. Now we should be able to ping from BC1 to BC2 now. So if we come here and try to ping, now we are pinging. Let's see what is the path selected by this traffic. So let's reduce this window a little bit and try trace route. The command in Windows is trace RT, which means trace route 10.0.1.10. So I'm tracing the traffic from BC1 to BC2. I want to know hop by hop which path will be selected by this traffic. Does it go through ISP1 or ISP2? So this is the command trace route 10.0.1.10. And let's see step by step. So first of all, the PC sends the traffic to its own gateway. Because the destination is in different subnet, the PC is configured to send anything which is not in the same subnet to the gateway. So the first hop is 10.0.0.1, which is this interface. Then the next hop is 10.0.255.1. Because this router doesn't have this subnet as directly connected, it will send it to the default gateway, which is 10.0.255.1 in this case. Now in this router we have a static route that says if you want to reach this subnet, send the traffic to the next hub, which is 10.0.255.10, which is this one. And then for this router, this subnet is directly connected, so it will send the traffic directly to BC2. So we make sure now that the traffic goes through this path. We know that the traffic goes this path as first hop, second hop this way, third hop this way, and fourth hop this way. Now what happens if BC or if ISP1 is down from both sides? If we shut down these interfaces, the connectivity between BC1 and BC2 will be disconnected because the default route in router 1 is pointing to this direction. So what is the solution? How can we ask this traffic to use this path only if this link is down? This is the function of floating static route. Before configuring it, let's see what happens when both interfaces in router or in ISP1 are down. To simulate that setup, we conft then interface gig 000 shut down, and we do the same for the other interface, shut down. So now both interfaces are down, and once it is down from this side, it will be down from the other side also. So let's try now to ping from BC1 to BC2. And for sure we cannot, because now router 1 will remove this default route because the next hop is unreachable. So just to verify, if we come here and try show IP route, so although we have this route added to the configuration, but because the next hop is unreachable, that route is not added to the routing table. So we still have the configuration for that default route, but because the next hop is not routable, is not reachable, the route is not added to the routing table. And this means simply that the router will drop any traffic to any destination not specifically in this routing table, and this includes the traffic to subnet 2. How to make sure that router 1 will use this link, ISP2. In case ISP1 is down, we configure a floating static route. Floating static route is the same as the default route, but we add administrative distance. So how to add that one? This is the command, which is similar. So we say conft IP route 00000000. Then we add administrative distance. If you type a question mark, you see that if you add a number here after the subnet mask, after the next hop, sorry. So we need to configure the next hop first, which is in our case 10.0.255.5. Then question mark, and you see if you add a number here, that number is the distance, which is the administrative distance actually. So I'll configure it as 5. Now we need to do the same from the other side, because routing should be from both sides. So on the other side we add a floating static route 10.0.0.0.0.0.0. The next hop is 10.0.255.13, and the distance is 5. Now we added a floating static route from both sides that says if this link is down, send the traffic to this path, and the same here. If this link is down, send the traffic to this path. Now let's see what happens from BC1. We can ping, and now if it is trace route, we see the traffic goes to the gateway 10.0.0.1, then 10.0.255.5, which is this interface, and then 10.0.255.14, which is this interface, and then to the PC. Now the question is, what happens if this interface is up again? Do you think the path will choose, or the router will choose this path or this path? Let's see. So we go back to our router. This is something extra. It is not in our lab, just to make sure that you understand what we did. So we are in ISP1. I'll go to, I will enable the interfaces again. The command is no shutdown. And the same here, no shutdown. So the router here right now has 2 default routes in the configuration. It has that route pointing to ISP1 with the distance of 1. The default distance is 1. If you don't write the distance, it is 1. It has another route pointing to ISP2 and the distance is 5. If we see the routing table, as expected, the default route that points to ISP1, 10.0.255.1 is ISP1. That route is preferred and added to the routing table. The other route is not considered. It is not in the routing table at all, because it has a distance of 5, and this route is valid. The next hop is reachable, so the router will not consider anything that point to the same next hop or the same network with higher distance. So if the router has 2 routes pointing to the same subnet but with different distances, it will only select the one with lower distance and will neglect the other one. As long as the route is valid, the next hop is valid and reachable, this one will be installed, the other one will be neglected at all, not considered. If for any reason this route is not reachable, it will be withdrawn, it will be removed from routing table, and only at that time the router will consider the other route. So now, as you can see, the router only installed the route pointing to ISP1. The distance for this one is 1, and it is now installed in the routing table. And to make sure that things go through this path, we can ping again. And we can also trace route. So the traffic goes to 10.0.0.1, then 10.0.255.1, which is this one, 10.0.255.10, and then the next hop. To show you the routing table from router 1 when the interfaces are down again, let me shut down the interfaces again. Just to compare the routing in the router 1. Now you see the default route right now is pointing to 10.0.255.5, which is this one, and the AD is 5, the distance is 5. It was 1 before when it was pointing to this interface, ISP1 it was 1. When it points to ISP2 it is 5. And this route now is considered because the original route is not reachable and not valid. It was removed from the routing table, and only in this case the other route will be preferred. As a result, the router will always send the traffic to ISP1 as long as ISP1 is reachable. At any time, if ISP1 is not reachable or down, or the link is not reachable, the router will switch immediately to the backup link. That's all about this lab and about this setup. Thank you.